Okay, in this video we're going to talk about models for addition of integers. Okay, and the first thing we're going to do is talk about the chip model. Now notice that my chips that I have are actually little squares, and I either have an option of making them red or yellow, and I'm going to use a red square as a negative and a yellow square as a positive. Okay, now you could use, you could use the other way, but what I'm going to do is using this particular model. Alright, so what I'm going to do is, using chips, I'm going to model a positive 5. So if I model a positive 5, that means that I'm going to model with 5 yellow chips. Okay, and could be color tiles, the circular color tiles. I'm just choosing to use these. Okay, so I have 5 yellow chips, and to that I'm going to add 2 more yellow chips because they're still positives. And then when I count these chips together, then I have 5, 6, 7, which is a total of 7 yellow chips, or 7 positives, which is the same thing as just plain old 7. Okay, in the second problem I have a positive 5 again, so we'll move these over to the next problem, and now I want to add negative 2 to that. Alright, now here's the trick. Okay, what I have is I can only have one color of chips to represent this number. So what I have to do is I have to find 0 pairs. Now, a 0 pair would be a positive and a negative. And think of that, for example, using money. I give you $1, I take $1 away from you, then that leaves you with no money. So this is a 0 pair. So what I'm going to do is I'm going to identify and what we call ring or circle 0 pairs. So if I circle this 0 pair and I circle this 0 pair, then I can take them away. So I'm left with 3 positives. Okay, so positive 5 and negative 2 is positive 3, or just plain old 3. Alright, in the third problem example that I have, I'm probably going to zoom in here, and hopefully maybe you could be able to see a little bit better here. In the third problem example, I'm going to have negative 5. So that means that I need 5 of these red chips. Okay, so I have that. Okay, and to that I'm going to add positive 2, which would be the yellow ones. So then again, I can only have one color of chip. So this is a 0 pair, so is this. So I can remove those, which leaves me with a negative 3 red, which means negative 3. Okay, now in the last one I have negative 5, and to that I'm going to add negative 2, so that I would take there and count those, because they're all the same. I don't have to take anything away by circling 0 pairs, because they're not. They're all one color. So this would be equal to negative 7. Okay, so this is addition using the chip model. Okay, now let's think about the chip model, and let's look at subtraction. Okay, with the chip model. Alright, so let's take a look at this first subtraction problem, which is 2 minus 3. Okay, so I'm going to start out with 2, and then I need to take away 3 chips. Well, I don't have 3 to take away. Okay, So in order to take 3 away, I have to have 3 chips. But I can't just add that 1 chip because it changes what I have to begin with. What I have represented has to be a total of 2. So if I look at this, this is 1, 2, and then this is a 0 pair, so this is really nothing. So basically what I have is, if I look at this now, I need to be able to take 3 away, so I needed 1 more. So I had to be able to count 3 positives. Now, in order to do that, I had to add my 0 pair. So now, if I take away 3, that means take away 3 positives, okay? Then that leaves me with 1 negative. So 2 minus 3 is negative 1. Okay? Let's go to another one. Let's do negative 2 minus 6. Okay? So I start out with negative 2. And remember that minus, we talked about this earlier in the models that we used with just addition and subtraction of whole numbers, that the minus is another way to say, can be said as take away. So negative 2, take away 6. I don't have 6 to take away, so I have to put 6 on there. I don't have any positives at all, so I need 6 positives. Okay, so I'm going to put my 6 positives here. Alright, but I can't just add 6 positives. Okay, I can't have anything different than negative 2. So what I have to do is add 6 in the form of 0 pair. 0 pairs. Okay, so basically I've added 6 0 pairs. So you with me here? So I've got 1, 2, 3, 4, 5, 6 0 pairs. Okay, so now then what I have is I've got a negative 2, and now I can take away 6. So if I take away 6, that's these up here, okay, then I'm left with how many here? So if I count all these together that I have left, 1, 2, 3, 4, 5, 6, 7, 8. So the answer to negative 2, take away 6, is negative 8. Okay, now let's look at this problem. This one's a little bit different. Let's say I have 2 minus negative 3. Now, sometimes that'll be shown with 2 negatives just like this, and sometimes it'll be shown with this in parentheses. So if we start out with 2, that's a positive 2, and I need to take away negative 3, well, I don't have any negatives to begin with. So I have to add negative 3. And remember, if I put those 3 down, I have to put it down in the form of a 0 pair. Okay? So that means I'm going to have to put this down like this. So then this gives me, in order to take 3 negatives away, I have to put 3 negatives on there, but I have to do it in the form of a 0 pair. So now I'm starting out with negative 2, because exactly what I've got here is negative 2. Because that's negative 2, and then that's 0, 0, 0. So negative 2, now I'm going to take away negative 3. So if I take away negative 3, that's these, then I'm left with 1, 2, 3, 4, 5. Positive 5. Okay, now let's do negative 6 okay, minus negative 8. Okay, so let's start out with negative 6 Okay. And I want to take away -8. Well, I've got 6, but I need 2 more. So then I'm going to put my other 2 down over here. Let's see. Let's put those 6 together and scoot those there. Alright, so there's my 2 more that I add, but remember I have to add it in the form of a 0 pair so that I can do here. So this is really -6, all of this is, because these are 0. Alright, now, so I start out with -6, and I want to take away -8, so that pulls all of these away. And I'm left with +2. Or just plain old 2. Just remember that in integers, anytime you have a positive number, it's automatically an unspoken. Alright, so using the chip model then, we were able to model addition and subtraction. And here are some things that you need to remember in terms of rules for addition and subtraction. Let me zoom back out here so you can see. Okay, so then rules for addition and subtraction. Okay, so anytime we add and subtract, okay, or addition and subtraction, okay, if we have the same signs, okay, we're going to add, and if we have different signs, we're going to subtract. And when we're adding and subtracting, the sign of the answer is always sign of the large number. Okay, now if you can remember that, you can add and subtract anything that we have. Now let's go back and look at the problems that we did with the manipulatives. Okay, so let's zoom in here on this one, and let's take a look back at this positive 5 plus 2. So same sign, so they're both positive. So we're going to add them and get 7. The answer is just sign of the big number. Now, if there is no sign here, it's automatically understood that this sign would be positive. Okay, let's look at the second one. Positive 5 plus -2. Alright, signs are different. So we're going to ignore the signs and take the big number minus the small one. So that would be like 5 minus 2, which is 3. Sign of the big number is positive, so the answer is positive, which is exactly what we got with the chip model. Alright, in this problem, we have a -5 and a positive 2. Signs are different, so we're going to subtract. So 5 minus 2 is 3. And the sign of the big number is negative, so my answer is negative. I get exactly the same thing that we got when we did the chip model. And the last problem is -5 plus -2. Signs are the same, so we're going to add. 5 plus 2 is 7. And then the sign of the big number is negative, so my answer is negative, which gives me exactly what I got when I added with the chip model. Okay? Now, let's look at the subtraction problems that we had. Alright? So let's look at this first one. I have 2 minus 3. So this is like a positive 2 minus a positive 3. Okay, signs are the same. And I'm going to subtract. So my rule for subtracting is to just look at this as the sign of the number. Well, I can look at it two things. This is like saying 2 plus -3. In other words, I'm changing this sign because this minus means to change the sign to the other sign. So then I have signs that are different, and I'm going to get 3. Oh boy. I'm going to get 2 minus 3. So the signs are different, so we'll subtract and get 3 minus 2, which is 1. And the sign of the big number is negative. Now, the other thing you can think about when you go back to the problem we had initially, we got 2 minus 3. Just think of this sign that's in front of the number as the sign with the number, so that's +2, -3. Signs are different, so subtract 3 minus 2 is 1. Big number is negative. Okay, now the second one here, if we think of this, this is like -2 plus -6. Signs are the same, so we add. 6 plus 2 is 8. Sign of the big number is negative, so my answer is negative. Okay, and if we think of them as the same as the sign in front of the number is the sign that goes with the number, then we have same sign, add, get 8, sign of the big number is negative. Okay, now the last one here is just a little bit different because we need to remember what this negative sign here in the middle means. This is 2, and then it says add the opposite of -3. So that's a +3. Okay, well, that looks like a flower, doesn't it? Okay, so then the signs end up now, after we get rid of this parentheses and the double negative there, we end up with 2 plus 3, which is 5. Big number's positive, so the answer's positive. Now, another way of thinking about these signs is anytime we have them in succession, like that, okay, I have 3 of them there. So we're looking for pairs. So anytime you have a pair, here you have a pair of 2. Anytime you have a pair, the answer is positive. In other words, this is the same thing as a +3. This one, I have a pair, but I've got 1 left over. So it's an odd number there. So if I had something like 3 and then all of this, then I would write these 3 negatives then. Pair leaves me with 1 left, so that would be 3 minus 2, which is 1. Excuse me. Okay, and the last problem that we had here, again, that's the same thing. That's a pair, so this is really -6 plus 8. Now, signs are different, so we subtract and get 2. Big number's positive, answer's positive. So we've used the chip model and then the actual rules for addition and subtraction.